Rachel here for Wonky Chart. If you're practiced at reading charts and terms like constant dollars and GDP don't send you running for a dictionary, you can probably skip this. If charts aren't part of your daily routine, stay tuned. Charts are nothing more than values represented visually by columns, bars, pies, lines, and dots. Instead of wading through columns of numbers, charts help us see how data relates and changes, usually over a period of time, at a glance. They make it easier for us to connect the dots. The caveat is all data can be manipulated. What's left out of a chart can be just as critical as what's in. We also usually provide the same data in a variety of ways. Some perspectives are better than others, but we make charts available in the most accepted formats. Let me show you what I mean. This chart shows total federal spending from 1940 to today in what are called period dollars, also often referred to as current year, unadjusted, or raw dollars. All this means is a dollar equals a dollar whether it was spent in 1940, 1964, or 2011. Looking at this, it appears our government started spending like drunken sailors late in the 1970s. Now look at this. The price of a common food item we all use looks pretty much the same. If I had a time machine and went back to 1940 and brought my grandfather, who really was a sailor, back to today and sent him to the store to buy a loaf of bread, he'd have a coronary on aisle 11. Why? Because from his 1940 perspective, a loaf of white bread should cost 15 cents. I bought this loaf today at a supermarket for $2.49. You might pay a little more or less where you live, but $2.49 is close enough. We buy bread for an amount at this vicinity and think nothing of it. That's what bread costs. What does this chart track? The price of a loaf of bread since 1940 in current dollars. Almost all charts spanning a long period tend to look similar because period dollars don't take inflation into account. Period dollars are fine for looking at 5 or 10 years, anywhere along a timeline. When you go past 15 or 20 years, the data becomes increasingly distorted. Are the numbers accurate? Yes. But they're distorted by our perceptions because our frame of reference is 2012. $2.49 would be beyond outrageous to Granddad because it would be a huge chunk of his 1940 paycheck. Say you earn $1,000 a week. It's about the median for a family today. Factor for inflation, and $61.50 would have given you roughly the same purchasing power in 1940. If my dad had plucked his grandfather out of 1913 and brought him to 1980, he would have been just as horrified paying 89 cents for that loaf of bread. He was used to a price of around 11 cents. Let's examine this a little closer using World War II. It's far enough back and the scope of the war distorted government spending and the economy so much that the differences are easier to see. The 1940s in period dollars. There's a bump for World War II, but nothing like you'd expect. Looking at this, America fought the war at Kmart prices. The US had 15 million people in uniform, conducted massive campaigns all over the Pacific, Europe, and Africa. Almost all of our industrial capacity was devoted to turning out ships, planes, tanks, artillery, everything it took to fight a global conflict. At the start of the war, the US had 4 aircraft carriers. By the time it ended in 1945, the fleet had over 40. The same decade in constant dollars, also referred to as chained, indexed, and adjusted dollars. What you do to arrive at constant dollars is to pick a year, the current standard is 2005, and designate that $1 equals $1 for that year. Then you apply a standardized deflator table to the other years to arrive at constant dollars. The big difference in the amounts, and just as accurate as period dollars. Trying inflation tables simply adjust sums of money to more closely match our perspective. In this case, looking at events 70 years ago, constant dollars is probably the best way to go. Here's another common method. This is government spending for the same decade displayed as percentage of gross domestic product, called GDP for short. The dictionary defines GDP as the total value of goods produced and services provided in a country during 1 year. An easy way to think of GDP is as our national paycheck. When we divide an amount by GDP, the product yields the percentage of GDP a particular amount represents. In the case of government spending, 43.6% of GDP was devoted to fighting World War II in 1943 and 44, almost half of the national paycheck. Yet another common way used to look at how big a piece, defense, or anything else government spends money on for that matter is, in relation to government, is to narrow the universe to just federal spending, like you see here. Defense spending gobbled up 89.5% of the government's budget in the last year of the war. Fighting World War II was about all the government did that year. By 1948, defense was down to 30.6% of all government spending. The government went back to peacetime life, and the resources our government allocated to defense reflected that. Another common method you'll run across is ratios, or indexed values. This works similar to inflation-adjusted dollars. A benchmark is picked, like say 2005 if you're comparing year to year, and assigned a value of 100. The other things you're measuring are compared to that benchmark and assigned a lower or higher value depending on the relative quantities involved. And a final word about GDP. Each quarter and annually, the Bureau of Economic Analysis, usually called BEA, releases GDP figures for the US. You'll see either just plain GDP or real GDP. GDP is just like period dollars. No adjustments are made to account for inflation. Real GDP means the BEA factors in the effects of inflation as it goes. As a general rule, real GDP numbers tend to be slightly smaller than just plain GDP. You'll see real GDP used most often. Let's cover the common types of charts and how to interpret them, and we're done. One of the most common is a pie chart. Slices represent a portion of the whole pie. The values are usually expressed as a number or a percentage. Here we have a pie chart representing Social Security's revenues and how the agency allocated them. The line chart is also commonly used. Data points are input to an application that makes charts like Keynote, PowerPoint, Excel, or Numbers, and the program draws a line connecting the points in a series. Line charts are excellent to plot ups and downs in a succession of whatever you happen to be measuring. Column charts feature, well, columns that represent a value. That value can be money or just about anything. Bar charts are nothing more than columns turned sideways. The what, in terms of what you're looking at, such as an amount of money or types of widgets or whatever, is usually defined on the x-axis, the line running horizontally along the base of the chart. The how much, the value, is usually on the y-axis, the border running up and down. Except on bar charts, where the x and y are almost always reversed. What is up and down, how much, rungs along the bottom. A word about scale. This is a chart with a base value of 0 running to 100%. You can't really see much because the values place the lines close together. The way to clear that up is to shorten the scale range to achieve more separation so that differences are easier to see, like this. It's the same chart. All that's been done is to tighten the low value from 0 to 15% and drop the top range from 100% to 25%. We tend to stick with basic types in Wonky chart. If you're doing this, trying to figure out a chart, you're not having a lot of fun, and that definitely is not the idea. Now, go have some fun.